Hey guys, I just want to talk to you about something real fast. First, I want to draw you a picture. This is supposed to be grass. It's kind of hard to do with one hand. Okay. Trees. Trees. Here you are. Here's the sun. Woo! Hold on. Clouds. Clouds. Or clouds nowadays. Hashtag. Birds. Birds. Here's you are. Yay, it's a wonderful day. We get to do activities. It's morning time. Sun's up, shining. And then sometimes you see a what? A moon. In the daytime. Who's all seen a moon in the daytime? Yes, everybody has. Or if you've ever seen a total eclipse, this will work for it too. All right, so here you are. You are on what? What planet? Does anybody know? Dun, 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 dun. You are on, bam, Earth. I live in America. Oh, snap. I live in America. Hashtag I love America. This ball is like, whatever, but there's America. It's supposed to be America. There's Brazil, Africa, Russia. For some reason, they have the Antarctica as green. There is Australia-ish. These are all issues because they don't, that's probably Greenland or something up there. That little dot or something, I don't know. And then there's the North Pole up here. So, I live in America. Hello, America. Hello, hello, hello. Hashtag America. Oh, there's Canada up here. There's America. There's Florida, the little tail. Huh? Actually, that's backwards, isn't it? Because the tail should be over here. Texas is the tail. The other tail. Whatever. Yeah, so we should have a little tail over here. But they don't. But anyways, that don't matter. Anyways, so that's America. This is where I'm from. I'm from Ohio, which is like right over there. Okay. So I'm going to use this as an example, if I could get it to stand. Okay. So, here we are in America. It's about to be morning. So, well, it is morning compared to how I'm doing it right now. It's daytime. Here, it's coming. It's daytime because this half is lit up over. Let's say this is actually the line right there. We can use that for the line. So right now it's becoming morning. Because right here, right when this line hits the vision of the sun or the rays of the sun, that's when it starts becoming morning. So this light right here is a reflection of the light. Not from the sun though, obviously. That's a piece of paper, but hashtag, I just wanted to clarify that. So it's coming now. It's daytime. And then this side is what? What side is this, guys? Do you know this side? That would be night because the sun's over here. So this side will be night. So what I want to talk to you about today is when you, my little thing is not wanting to stay. Hold on. Pause. Let's see if it stays now. Probably not. Where's America? There's America. This probably won't help it either. Okay, that's a little better. Okay. So what I want to talk to you about is when America is seeing the sun and the moon at the same time. And no, that's not to scale. But in a lunar or in a total eclipse, the moon moves in front of the sun and it blocks the vision from Earth to the sun. And it makes a ring around the moon, like this. Hello, moon. Sun. Which is actually pretty cool. But for this to happen, and to see, even if you don't use an eclipse, just say that you just see, it's just a normal day, and you see a crescent moon in the sky. No, that looks like an upside down chicken wing. But whatever. So say that you see that on this side of America, or whatever you're at, wherever you're at. This will work wherever. This side over here has to be without any moon or sun for that to work. So even if I flip it around, like say I flip it around where these people over here see the sun and the moon, this side back here is still without. First of all, that's a lot of whatchamacallit, because this is not to scale at all. But this part over here is without any moon or sun. Have you ever looked up in the sky? Ever. Period. So let's go back to America. So have you ever looked up in the sky and seen a sky without a moon or a sun? Now, we're on an axis, so it's like this. So yes, like there is times that like it gets extremely dark and they go without the sun, and up here, like in Alaska and stuff, and then down here, I believe. So yeah, them, but definitely at the equator, you have never, ever been without the sun and the moon. At least one of them. But what they're saying is that when you see both of these at the same time, how does the other side see it? On a sphere Earth. It wouldn't be possible. It would not be possible for you to be able to see the sun and the moon at the same time on one side of the planet and them seeing it on the other side of the planet on a sphere Earth. But yet, a lot of the times, like I've woken up plenty of times and seen the sun and the moon at the same time. And not just with the total eclipse, but with the total eclipse, like they tell us exactly what a total eclipse is. That our one sun gets covered up by our one moon. And we get this little shine, little shimmy, shunga. And then we can see it on Earth. Hey, total eclipse. Yay, that's so cool because it only happens every once in a while. But don't look too close because sometimes it hurts your eyes. So no matter where you are, there's always going to be a dark side of the planet. Look at all that water. This is definitely not to scale. But it's not supposed to be because it's not a real globe. It's just a stress ball. But it's the closest thing I had right now. So, so please tell me that. Please tell me how that is possible. That we can see on one side a sun and a moon, but on the other side they still see one orb. Like, they never are without a sun or a moon. Ever. Ever. I just want you guys to do one thing.